Good morning, class. We are in section 5, the last section we're going to do of the review chapter. And the topic is nonlinear functions and models. So we're going to graph nonlinear functions and solve applied problems. That means we're going to do parabolas and other quadratics and maybe even other polynomials. We're going to manipulate radical expressions and rational exponents. We're going to determine the domain of a rational function, and we're going to graph rational functions. And then the business applications, we're going to find the equilibrium point given a supply and demand function so that we can learn how to apply these to business. Let's get started. Let's go over some basics of the quadratic function. The quadratic function is given by f of x is equal to ax squared plus bx plus c. We want our a coefficient to not be 0, otherwise this wouldn't be quadratic anymore. The graph of a quadratic function is called a parabola. A parabola is a cup-shaped curve. I would call it U-shaped. It opens upward if my leading coefficient is positive. Our leading coefficient is a. And we say something is positive by saying it's greater than 0. So it opens upward if a is greater than 0. It opens downward if a is less than 0 or negative. It has a turning point or vertex, which is the first coordinate given by the formula x is equal to negative b over 2a. And that equation also is the line of symmetry. So the line of symmetry is where that graph becomes mirror image. Let's go ahead and do the first question. Question number 1 asks us to graph f of x, which is x squared plus 8x plus 15, but it also asks us to find the vertex and the axis of symmetry. So before we start filling in values on the t-chart, I want to find that vertex using the formula x is equal to negative b over 2a. I'm going to use this formula to find the x value, and I'm going to get negative 8 over 2 times 1. I'm getting these values from the b coefficient and the a coefficient. And so I have an 8 and an invisible 1. And so I get negative 8 over 2, which is negative 4. That is the x value of my vertex. So to find my y value, I'm going to plug that into my function. You say, what's f of negative 4? And make sure that when you plug in a negative, you always want to put parentheses. So we're going to say negative 4 squared plus 8 times negative 4 plus 15. That turns into a positive 16 and a negative 32. And that gives me negative 1. So my coefficient, or my coordinates, will be negative 4, negative 1. Let's put that on the graph. And then to go further, I would usually pick points, x values on either side of that negative 4. So let's go ahead and do our t-chart now. And then picking values on either side. We're going to plug that in and see the values in our, for our parabola, for our quadratic. Go ahead and use a calculator if you want. You can plug that in. F of negative 6 is 3. F of negative 5 is 0. F of negative 3 is 0. And f of negative 2 is 3. So let's put that on the chart, on our graph. And then when you connect the dots, you do want to make it as U-shaped as possible. Try not to make it look like a V. It's a little bit hard to do. And then you want to put arrows on either end of that parabola. It does ask us to label our vertex. I labeled it negative 4, negative 1. And then I want to draw in the axis of symmetry through that vertex. Is going to be a vertical line. And it's going to be going through that vertex. And it is at x is equal to negative 4. So when you say x is equal to negative 4, that is a vertical line. And notice I did it in a different color. That is not actually part of the parabola. It is a feature of the parabola, but it's not actually one of the solutions. So we draw it in a different color. I make it a dashed line so you know it's not actually part of the graph. Look back at your work. Make sure that your graph is clean and is neat that it's visible that you have a parabola and that the axis of symmetry is not the same, it's in a dashed line or something like that, and that you have labeled your vertex, and you've also labeled the graph. You want to make sure that there's numbers on the x-axis and the y-axis, so that there's so that we know what the scale is on your graph. We're going to do that again. We're going to graph a function negative 4x squared minus 12x minus 5. We have to be careful because there's lots of negatives in this question. So when you use the formula, you have to use the negative, and then when you put the b, you're going to put negative 12, and then you're going to put the 2 and the negative 4. So notice that I have all these negatives. I need to simplify. I see 3 of them. 2 of them will cancel out, so I'll be left with a negative, and that's negative 12 over 8. Let's simplify that, and I get negative 3 over 2. In other words, negative 1 and 1/2. And I actually prefer this version of it, but I'm going to use a negative 1 and 1/2 to get to the right spot on the graph. Taking the x value at negative 3/2, we're going to plug that into our function. I get negative 4 and negative 3/2 squared minus 12 times negative 3/2 minus 5. Make sure when you simplify this you have the negative 4 coefficient. This square part becomes 9 over 4 positive. Negative 12 times 3 is 36 over 2. And those 4's will cancel out, so I'll just have negative 9 plus 18 minus 5. And that gives me 4. So we'll go to negative 3/2, or negative 1 and 1/2, and positive 4. So you're going to put your first dot, your vertex, right over here at negative 3/2, positive 4. And that's also going to be my axis of symmetry. Let's graph that in a dashed line. And we'll label it x is equal to negative 3/2. I put my values that I know on my t-chart, and I'm going to pick values near it that are easy to plug in. And let's just figure out what those values are. Once again, you can use your calculator. So we now have our t-chart filled out, and I went ahead and graphed those points on the graph. I made sure to connect those points with a U-shaped curve. Make sure it's not V-shaped, but that it's U-shaped, and that it have the vertex labeled and you have the axis of symmetry labeled, since that was part of the original question. Make sure you also have numbers on your graph on both the x-axis and the y-axis. And once we make sure we answered all the parts, we're done with this question. So far we've graphed 2 equations, and we also found the vertex and the axis of symmetry. What we haven't been doing is finding the x-intercepts. To do that, we set the function equal to 0, and then we solve. Remember that the real solutions are also the zeros of the function, and that those are also called roots. And so all of these are the same thing. When we solve that equation, we first try to factor, and then use the zero product property to solve each factor for 0. But when factoring seems difficult, then we can either complete the square or use the quadratic formula. The quadratic formula is given to us right here. X is equal to negative b plus or minus the square root of b squared minus 4ac, the entire thing over 2a. We're going to use that now to solve video example 3. When we're asked to solve a quadratic equation, one of the first things we want to do is make sure it's in quadratic form. That is, we want it to be in descending order of exponents, and then we want it to be set equal to 0. We're going to do this by subtracting 7 from both sides. And then, just like the steps above say, We're first going to look at this and see if we can factor. And I notice that I have 3x squared as my first term and negative 7 as my last term, and those are both prime. And I can't think of a way to factor this where they can either add or subtract to make 2 as my middle term. So I'm going to go ahead and use the quadratic formula. We're going to label all of our variables. This first coefficient 3 is our A, 2 is our B, and negative 7 is our C. So make sure you identify all the variables first, and then we can plug it into that formula. It's important when writing the formula that you put the negatives where they belong and the fraction under the entire thing, and that when you substitute values in, that you make sure you pay attention to the signs. We get x is equal to negative 2 plus or minus the square root of 2 squared minus 4 times 3 times negative 7, the whole thing over 2 times 3. And then simplifying this, we get x is equal to negative 2 plus or minus the square root of 4 plus 84 all over 6. Then we get x is equal to negative 2 plus or minus the square root of 88 over 6. We're going to simplify 88. I know that 4 goes into that, and 4 is a perfect square. And then that would go in 22 times. 22 is divisible by 2 and 11, both of which are prime, so I can't simplify that anymore. So what I can do is take the negative 2 plus or minus the square root of 4 is 2, rad 22 over 6. And I'm going to factor out the 2. So if I factor out a 2, I get negative 1 plus or minus the square root of 22 over 2 times 3. So I can factor that 2 out of both the numerator and the denominator. And I'm left with negative 1 plus or minus the square root of 22 over 3. It's important to keep it like this. Make sure that the negative stays in front of the 1 and not in front of the fraction. And there we go. That's our solution. That's actually 2 values. We have 2 x-intercepts here. If I wanted to simplify it, I could ask my calculator, and I could actually calculate what decimal approximation we would have my x-intercepts. But it just said to solve, so those are my 2 solutions. These next 2 questions I'm actually not going to graph in this video. I'm going to ask you to graph it on your calculator or by looking up the textbook answers. But I do want to talk about the domains of these 2 types of functions. Polynomial functions are functions with a domain of all real numbers. We write all real numbers as an interval from negative infinity to positive infinity. Another shorthand way that we write all real numbers is capital R with a double line for that first line. And so that's how we say all real numbers. But typically we want to write it in interval form, so it's going to be from negative infinity to positive infinity. Now for rational functions, the domain is all the real numbers except where the denominator is 0. As shorthand, instead of writing that whole sentence, what we can say is that the denominator cannot be 0, and as we solve that inequality, we'll find the numbers that will not be part of the domain. Notice for that function given on the left, where it says f of x is equal to 1 over x, the denominator here is just x. So if I say that the denominator cannot be 0, I'm saying that x cannot be 0. But if my denominator was something else, then perhaps my value of x could be 0, but it could not be something else. For example, looking at g of x as 1 over x plus 3, I'm going to set my denominator not equal to 0. And when I solve this, then I find out that my x cannot be negative 3. It can be any number but negative 3. So if you said my domain cannot be 0, that would not be correct. my x value could be 0, because when I plug in 0 to this, the fraction is valid. But my domain is that my denominator cannot be 0. In other words, my x cannot be -3. So it's very important that you use the correct words. I'm looking for the word denominator when I'm looking for the rule for the domain of rational functions. Question number 6 asks us about an inversely proportional relationship between copier paper and the cost per ream. And I've sort of set up the flow of what we're going to be doing as we solve it. We're first going to be coming up with a generic equation, which is the generic equation for inversely proportional situations. We're going to fill it in with some information from this question, from the first sentence. That's what I call situation 1. As we do that, then we're going to solve for k. After I solve for k, we're going to put that back into the equation. We're going to get y is equal to blah 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 k value over x, and we're going to have our specific equation. We're going to put in information for situation 2, that's the last sentence in this question, and then we're going to solve for y. And so that's how we go about solving anything like this. There's actually a lot of information in here, and it's more information than you're going to put into an equation all at once. We're actually going to be solving in several stages. So we're going to solve for k first, and then we're going to replace k, and then we're going to replace x, and then solve for y. Let's look at situation 1. Joanna orders 30 reams of paper at a cost of $5 per ream. And we're also told that there's an inversely proportional relationship between these two items. So that's how we know we're going to use it in this equation. Let's call how much we expect to pay per ream our y variable. So that's going to be $5 in our first situation, and then how many reams would be our x variable in our situation. So we're going to say y is equal to k over 30, using all the information from the first step. I'm going to multiply both sides by 30, and I get 150 is equal to k. So that's my first step. I'm now going to rewrite my equation, specifically using the k is equal to 150. So I'm going to say y is equal to 150 over x. Now looking at this equation, we're asked how much can she expect to pay. So we're asking how much is her y when she orders 50 reams. So that's her x. How much she pays is her y, and how much she orders is her x. So that's what we call situation 2. I'm going to plug that into my specific equation. I want to find my y, and I'm going to replace my x with 50, and then we solve. So I say y is equal to 3, and let's make sure we have the correct units. It's $3 per ream. So once again, the way we're setting it up is generic equation, substitute in my y and my x to solve for my k, plug the k into the equation, substitute my x to be able to solve for the y. And then there we go, we have our final answer. Moving on to number 8, we're asked to graph f of x is equal to the square root of x plus 4 plus 1. And we're also asked to state the domain and range. And I encourage you to know the parent function, the square root of x. If you don't, pause the video right now and go look at the book example 8 and make sure that you're familiar with the parent function. But what we want to know is that the radicand in a radical has to be positive or 0. It cannot be negative. When we say that the radicand cannot be negative, we say it has to be positive or 0. These are words I expect you to know. Radicand cannot be negative, and the radicand has to be positive or 0. By saying radicand, we mean the part within the radical sign. So we're going to take that and write that it's positive or 0. So we're going to say x plus 4 has to be greater than or equal to 0. So x has to be greater than or equal to -4. This is our domain. Our domain then would be from -4 all the way to positive infinity, including the negative 4, not including positive infinity. Therefore, if I do a t-chart, I'm not going to put negative 4 in the middle. I'm going to put it as the lowest number this could be. So I'll put the negative 4 here, and then we'll continue on. When I plug this in, let's go ahead and put our answers down. F of negative 4 is 1. F of negative 3 is 2. F of 0 is 3. And F of 5 is 4. Let's go ahead and graph this. We know that negative 4 was the lowest number we could plug in, and as we're going, we are going to be graphing like a sideways parabola cut in half. And there we go. So our domain makes sense looking at this, because our domain is the lowest x value and all the values above that. But for our range, it's the lowest of our y values and then all the y values beyond that. So the lowest value is y is equal to 1, and then we're going to go up to positive infinity. Algebraically, you would say y is greater than or equal to 1. But we can put in interval notation. Our domain and range are right here. We've graphed it and we've stated the domain and range, so we're done with question number 8. When we're dealing with exponents, we want to recall some of the basic exponential rules. A to the n times a to the m means you're going to add the exponents, so that's n plus m. A to the n divided by a to the m, we're going to subtract the exponents, so that's n minus m. A to the n, the whole thing to the power of m, means you're going to multiply those exponents. And 1 over a to the m means that you're going to turn that power of m into a negative power. And so there we go. Question number 9 asks us to use our knowledge of fractional exponents to make them into radical expressions. And so remember that with the denominator of each fraction, that turns into the index of the radical, and the numerator of the fraction turns into the power. So let's go ahead and see what these look like. Y to the 1/5, that 5 is in the denominator, so that becomes my index. You get the 5th root of y to the power of 1, which we don't bother writing the 1. That's an invisible power of 1. Same thing over here for the next question. We got c to the power of 3/4. The 4 is my index, so that's the 4th root of c to the 3rd power. And then we have m to the power of negative 4/7. We're going to do the same work, but we're going to stick it in a fraction in the denominator of the fraction. So this negative in the exponent is what makes the fraction. The fraction is what makes the radical. So we're going to say the 7th root of m to the 4th, but we're going to stick it in the denominator of that fraction. And the same thing with d to the negative 1/3. That's going to be the cube root of d and in a fraction like that. Okay, so once again, the numerator of the fraction turns into the power, like we have the 4th, m to the 4th, and c to the 3rd. The denominator of the fraction turns into the index of the radical, and then the negative for the exponent turns it into a fraction itself. For number 10, we're going to do the number 9 in reverse, meaning we're going to start off with radical expressions and then rewrite them as rational exponents. Remember that the index of the radical, or the number within the radical sign, that becomes the denominator of the rational exponent, and then any power on the inside turns into the numerator. For instance, there's an invisible 1 on this x to the power of 1, but the 6 is the index, so that's going to become the denominator. This becomes x to the power of 1/6. For the next example, we have r squared inside the 5th root, and so this is the numerator, and that's the denominator. So that will become r to the power of 2/5. For this one, if there is no index, it's an invisible 2. It's probably the only time we have an invisible 2. So when I take this, I'm going to write it as x to the power of 8 over 2, which we can reduce to say x to the power of 4. And then this one is in the denominator. Let's go ahead and rewrite it once. It's going to be 1 over b to the power of 4/3. And that could be b to the power of negative 4/3. And there we go. We want to put a negative exponent and move the b up to the numerator. We don't want to leave the b in the denominator. So go ahead and put that negative on the exponent to pull it out of the denominator. For question number 11, we're asked to find the domain of the function given by f of x is equal to the 6th root of 15 minus 3x plus 4. And notice that we have a radical with some terms that are outside the radical. And there are no variable terms outside the radical, so we're just looking at the stuff that's inside the radical. Also, let's recall the rules about the domains of radicals. If the index is even, then the radicand must be non-negative, meaning the part inside the radical has to be non-negative. When it says non-negative, that means it has to be positive or 0. So we want to set this up to be positive or 0. So we're going to take the radicand. That would be this part and just this portion of it. And then we're going to say that the radicand must be greater than or equal to 0. That's how we write positive or 0. And then we're going to solve this by subtracting 15 from both sides. And then dividing both sides by negative 3. When you divide an inequality by a negative, you do have to switch that inequality around. So we're going to say less than or equal to. So x is less than or equal to positive 5. And so this is our interval that we're going to take. And that's our domain. We're going to write it as negative infinity to 5, including the 5, not including the infinity. And that's how you solve for the domain of a radical. Make sure that as you're doing this solving, you start off by the correct statement, putting the radicand in an inequality greater than or equal to 0 and using that inequality the whole way through. And so that way, if the inequality needs to switch directions, you can do it through the algebraic work. We're moving on to the last objective of this section. And the last objective was talking about supply and demand equations. And this isn't the first time we've talked about it. As you can imagine, this is quite important for a business class. So we want to make sure we understand how to work and find the equilibrium point of supply and demand equations. Remember that when they say to find the equilibrium point, what they're saying is find when the demand and the supply are the same. In other words, we want to set these equations equal to each other. And so we're going to take our two equations and we're going to set them equal to each other. We're going to say 350 minus 5q is equal to q plus 20. And let's go ahead and solve this, moving our variables to the same side. Adding 5q to both sides, I get 6q. And then I'm going to move my numbers all to the other side. So I'll subtract 20 from both sides. I get 330 is equal to 6q. Let's go ahead and divide both sides by 6. And I get 55 is equal to q. Let's go and see what q represents. In the question it says q represents the number of coffee makers produced in millions. Let's also find what p is when q is 55. I think this might be the easier of the equations to use. And so I'm going to replace q with 55. And I'll get 75. And looking back, it says P is the price of a coffee maker in dollars. So we want to put the correct units on that one as well. We'll say $75 per coffee maker. If the price is $75 per coffee maker, then there will be 55 million coffee makers produced, and the supply will meet the demand, and that would be 55 million coffee makers. Now, it's important to know that when you look at your equations, demand and supply, they're written as P is equal to 350 minus 5Q, and P is equal to Q plus 20. That means that our P is our variable that's dependent on Q. And when we write this in an ordered pair, we would do Q as our independent variable and P as our dependent variable. What I mean by that is we would put the Q first of the equilibrium point and then the P value of the equilibrium point if we wanted to write it as an ordered pair. So our Q value is 55 million, and then our price would be $75. And that's not always evident, but this one is the dependent variable and this one is the independent variable. You just need to know in which order to write your variables so that it makes sense. And that's our section for today. Thank you, and we're done with the review chapter.